Hello, this is the second episode of our series, The Aircraft and the Skies. In this episode, we'll be talking about aircraft wings and control devices. A lot of the emphasis will be on aircraft wings. As we go into this, I want to bring your attention quickly to the thought of wings. Wings have been around long before there were airplanes. Just see the birds in flight, in majestic flight. There's one here that I want to show very quickly to emphasize this point. See this bird? It spreads its whole wings, and when it's spread like that from tip to tip, that's called the wingspan. And it just flies. This is called a gliding flight. That's from nature. Okay? And it's things like this that we look at when we design the devices that will do that. Those things are looked at in nature first, and we say, wow, there's a device, there is a creature that's able to do this. Can we make a machine that can do that? And then the science begins, the applied science begins, and the engineering begins. So the things that we create are usually an imitation of what God Himself has provided for human nature, and we look at this for the wealth of our knowledge and our exploration. So let's look into aircraft wings. We have different wings for the aircraft. What does it do in the first place? The airplane can almost not fly without the wings. The airplane can, I repeat that, the airplane can almost not fly without the wings. Is it possible to fly at all without the wings? Yes, there are things called wingless aircraft these days, but primarily the aircraft needs wings or some kind of device of wings if it's to take the form of the traditional airplane. And so the wings are very important. Not to even talk about the attachments to the wing, just the function of the wing itself. It's a lifting device. Without lift, the airplane cannot stay in the sky. The wing is the substance, is the part of the airplane that sustains the lift that's acquired by the airplane. How is the lift acquired? Well, there are theories, but the predominant theory is the aircraft lift theory, which is basically the airfoil theory. What is the airfoil? Okay, the airfoil is essentially the shape of a teardrop. A teardrop goes down from the face, but if you look at a teardrop and slide it in the perpendicular direction to the direction it normally comes from. A teardrop comes like that, or a raindrop, comes like that to the ground. If you can turn it like that, so that's perpendicular to its natural direction of flow, then that would be the shape of the aircraft of the aircraft itself. But that's the shape of the teardrop, which is also the form of the wings we have. So a section of the wing of the airplane is what's called an airfoil. And the airfoil theory shows that there is greater speed on the top of the aircraft, or on the top of the wing, and lower speed on the bottom of the wing. The lower speed has greater pressure. The pressure pushes the upper portion, so the aircraft stays aloft. Yes, there's the power that's provided, but what uses the power to stay steady in the sky is the aircraft wings. And so we'll look at various aspects of the aircraft wing and the different designs of aircraft wing, and hopefully we will have some enlightenment about the wings. And who knows, some of us may go on to start to generate new wings. There's no limit to knowledge, and we may think, oh, they've all been found out, until somebody comes with a new one, and it's just as amazing as the first one that was introduced by the Wright brothers and their colleagues, their counterparts, when they were doing the aircraft. So let us look into aircraft wings. Welcome back. I started to talk about the wings of an aircraft and the mimicking of the wings of a bird to do the same. The majestic bird that we look at quite very well represents the parts of the wings of an aircraft and how it is designed, at least when it's first started, before we go on to making modifications to the wings of the aircraft. A wing, as we've said, is some type of fin that produces lift for the bird, for the aircraft, for most of the flying devices, even for the mosquito. The function is the same thing. In fact, it has been found out very recently, the research that's done with all creatures, whether they're biological, celestial, a lot of creatures that can be gotten. I think this was a study done in Oxford, and it was found that all these devices could be as small as a tiny mosquito, as large as a whale, use a specific dimension of the span of the wing from the body, and it's about two-thirds. About two-thirds of the span of the wing is what's used in flying. So flight becomes a common phenomenon that unites all these creatures in their obedience to physical law. And they use an appropriate range, a consistent range. And that could provide us something that would contribute to the advancement in the design of wings and flight components of our aircraft. Well, we have different types of wings. Long ago, when the Wright brothers and their colleagues and their predecessors started to design airplane, the airplanes that they designed were bi-winged. They had double-wing aircraft, as is shown here, and that was done because they wanted more lift. And so because lift is a function of the surface area of the airplane. So by having more than one layer of wings, they had more surface area. They also have greater structural strength. So they had greater lift, which is desirable, and greater structural strength. But these were connected by wires, and these wires added to drag. So they had much greater drag. Eventually, progress was made, and a single wing that is thicker than a single portion of the double wings that were made was then devised. So these days we don't have double wings and triple wings anymore. But they did fly. They did fly, and there was a reason for the introduction until better material and better knowledge of the wings were introduced. And here we see from the onset, from the beginning of the wings, the double wings, for example, the triple wings will go along that line back to typical Cessna, which is a common sports utility aircraft these days, then to the big transport airplane with its majestic wing span and just with trapezoidal form of wings. And to the fighter aircraft, delta wings that seem to have no tail at all. We'll talk about tail in subsequent lectures, but it's all wings, and it takes the form of delta. Delta is just the Greek alphabet, the capital Greek alphabet, and that's the form that the aircraft has taken. So we have these different types of wings with their sweeps, and these all perform essentially the same function: to keep the airplane aloft. Bottom line, to keep the airplane aloft. The different forms and different shapes they have because of the addition of landing gear or engines to them, those necessary paraphernalia, but the primary first function is to keep the airplane aloft for the wings. Okay. Here we have the triplanes, the triple wing airplanes, and the way this was done, when it was first done, is just like a child's play. As you can see from this diagram, it looks like they were just playing. They were building aircraft right at the corner in their house, and building the propeller, which was all wood at the time it started, by the way. And eventually it flew, So you build something like this, which looks like child's play, and eventually you get into the skies. So you get into the skies, then you think of production. And from production, you think of optimization. And before you know it, you're producing and you're selling this device to societies around. So we have the classification of wings. The wings are classified in different forms. They can be classified by wing layers, biplane, triplane, monoplane. They are sometimes classified by the speed realm, subsonic, supersonic, hypersonic. Subsonic is from very low speed, kind of speed you have in your small aircraft, which can be about 350 miles per hour, to a speed of 0.8, the speed of sound, up to about 0.8 the speed of sound. We still call that subsonic, and supersonic is generally 1.2 the speed of sound to about 3.8 the speed of sound is called supersonic. Generally, it's not a hard fact boundary, but that's generally how it is. And hypersonic goes from about that onward to the high end. There's a range about 0.8 to 0.8 m, the Mach number to 1.2, and that's called transonic, transonic speed range. That's transferring from the subsonic to the supersonic speed range. So that's, and of course, there's the hypersonic one, which is usually greater than Mach 5 or Mach 5 and above. The wings can also be classified based on their geometric shape. Rectangular wings, trapezoidal wings, moderate taper, high taper, elliptical wings, delta wings, swept wings, all kinds of wings like that. So those are some of the forms of the wings that we have for an aircraft. Wings are tested before they are used, just like any engineering device. Because you don't want it to fail in function, at least you want to minimize the chance of its failing. And there are different ways that they are tested, no different from any other engineering design, but particularly in these, great precaution is taken in the testing of aeronautical devices, because as you know, a vehicle can fail on the road, not desirable, but there could still be some containment. There's almost no containment in the sky if it fails, because there are three-dimensional areas of its failure compared to two-dimensional when it's just on the ground or when it's even just on water sometimes. So great care is taken, and that's why usually in aeronautical devices there's tighter tolerance made to the manufacture of the components. So one of the ways of testing the wings is in service. So the wing is already built, and then you're testing the prototype to see the performance of it and the reliability of it. This is very expensive. It was what was first done when this business of engineering know-how began, and it is expensive, and so people have moved mostly from it. There's still in-service testing, but in-service testing now will be necessary maybe for just one built prototype instead of 20 built before, until they get a good one, because there are many other methods by which the test can be improved before the real one is built and it's used. One of the primary methods that was used before the Wright brothers, by the Wright brothers, and still used today is the wind tunnel testing. About in the 70s, we used to joke in the aeronautical labs. We will say, oh, about 20 years from now, the wind tunnel will just become a repository for computational data and everything. Well, we were wrong. The wind tunnel is as useful now as it was then, and it's actually gaining more use because of the various improvements that are made to it. So the wind tunnel is a very prominent component of testing devices. In fact, a lot of the data that's used today, and many of the data that are used as constants or that are used in equations, they are data obtained from a lot of tests that were done by the wind tunnel. So that's a very prominent component and a very useful part. We will have other times to talk much more about the wind tunnel. We'll just say a little bit about it and now with other things. Another method of testing the wing is by analysis, computational testing. We've gotten data, again, thanks to the wind tunnel, we're able to get some data that we use in our equations. It's essentially a theoretical approach, fundamentally, then some other known data is added to it. So it's a combination of data until we come to a well-proven test result based on past computational methods. And then there's the simulation. Simulation is, in a way, kind of a computational approach, but this, the wing is essentially provided and electronically done. So we have a soft wing. It's called a soft wing. It's not the hard one. It's not the real wing. It's one that's been generated on the computer, and we do different things to it, and we see what happens in the computer before the real one is built. We talked earlier about the wind tunnel. It's for measuring parameters of flight vehicles primarily, and for the wind tunnel, come in different forms. There's the low-speed subsonic wind tunnel. Low-speed subsonic wind tunnel just means a wind tunnel that does not give you results for operations greater than Mach 0.8, because that's the high-end speed for subsonic. In fact, the low speed just goes to about Mach 0.4, and the high-speed subsonic goes closer to Mach 1. That's goes to Mach 0.8, and it will generally start from Mach 0.4 or 0.5, and that's called the high-speed subsonic. And the wind tunnel could be closed circuit or open circuit. Then we have the supersonic tunnel, we have the shock tunnel, and other types of wind tunnel. There's even the water tunnel sometimes. Well, the aircraft wing essentially consists of the following things: the aileron, the flap, and in some advanced vehicles, advanced aircraft, the slat and the slots. And we will show you in the diagram for the aircraft where these function. But essentially, the aileron is a control device, kind of supporting the control devices that are prominent in the tail. It helps in the aileron helps in the turning of the aircraft because the correct turning of the aircraft is called banking. It's a three-dimensional turn. You use the aileron in doing that, where, say, one portion goes up and the other wing goes down. The flap is essentially a descending or ascending device in the aircraft. Then the wing, of course, the structural strength is very important, and in the structural strength, a number of things are considered. Is it the high-wing aircraft? Is it the low-wing aircraft? Is it the mid-wing aircraft? Or in very rare cases, is it the wingless aircraft? And there are conditions for the generation of these types of devices. That is, whether we want a high wing or mid-wing or low wing, because there's a structural integrity that it has to have with the body of the aircraft, the fuselage of the aircraft. These are the things that are critical about the wings of the aircraft. And we will explore them further as we go on in subsequent series into the details of these component parts. These are just meant for introductory parts, and hopefully you would get yourself interested and familiar with the various terms of them. Thank you.